All right, now we're moving on to oxidation numbers. So a general rule of thumb, there is a general trend when it comes to oxidation states. So as you can see here, we have these various groups of elements. We know that these groups go by columns. So we know that group 1A is the earth metals, and we know that group 2 is the alkaline earth metals, or the rare earth metals, so one of those. And then you have that last group, the 8A group, that is the noble gases. Then you have group 7A, that's the halogens. So thinking about this going forward, all of these elements naturally carry an oxidation state, or the need to either gain or release electrons. So thinking about sort of a thing like hydrogen. Hydrogen has an oxidation state of 1, and it's carrying that 1 electron with it. If we think about a Bohr model or a Lewis dot model, yes, I'll be explaining more of the rules in a second, but thinking about a Bohr model, how we have those 2 electrons in that first shell, and then we build up to the 8 afterwards, and we build up on those shells of electrons. Well, this is kind of sort of the same thing. Hydrogen only has 1 electron, in its shell, and as such, it wants to do something with that electron, and that's what all of these oxidation states really tell you about a certain element. So if you go to the next slide, we have a few rules, general rules of thumb when it comes to assigning oxidation states. So pure elements are assigned a 0 for their oxidation number. 2 monatomic ions will have an oxidation number that is equal to their common charge. So that's kind of what we just covered. No, that's good. That extra bullet point. It's kind of what we
Okay.
just covered. It follows that general trend, of depending on which group, it kind of depends which, what what common charge you carry. If you want to go back to that periodic table, again, really quick, Alex, for me. We can see that we increase by +1, +2. Then when it comes to transition metals are a little funky. They got some different rules, so they don't really follow a general
Ooh,
trend like the rest of the groups do.
that's not what I wanted to do.
No, that's all good. But as you can see, it goes from +1, +2, +3, and then plus or -4. With carbon and silicon, those essentially vary per situation, and then it goes back down to the -3, -2, and -1. So going back to the rules, yeah, we know that they follow that general trend. We also know that nonmetals can be a little weird. They aren't as clear and cut out as other atoms are. For instance, if you go to, like Alex just said earlier, hydrogen naturally carries a +1 oxidation charge, but it will be a -1 when it's bonded to a metal. So that's one of those special instances you have to keep aware of. Same thing with oxygen. Oxygen is normally carries a oxidation number of -2, but it can be +2 when it's bonded to fluorine. It can be -1 when it's bonded to a peroxide, and actually a -1/2 when it's bonded to superoxides. Um, and going forward with that, the most electronegative atom is naturally assigned to charge first. If all the atoms in a compound are nonmetals, it's kind of like a general rule of thumb. And last but not least, the sum of all of the oxidation numbers in a compound or ion must add up to the overall charge. For most neutral ions, the charge will be 0. But sometimes, you can have NH4 plus, and then you know that all of the oxidation numbers in that molecule itself have to add up to a +1.